Hello everyone, welcome back to the course. My name is Devang and I hope that you all are doing well. So in this video, we will be talking about Deque data structure. Let me just write its name, Deque data structure. Actually some pronounce it as Deque also. This data structure is different from that of the NQ and DQ function. Actually, when we studied Q, we studied two operations. First was NQ and the another one was DQ. Now this DQ function is used to pop an item from the queue. This is a data structure. This is a data structure. So make sure that you differentiate that and do not mix the two terms. Okay. So what is a DQ? What is a DQ? As the name suggests, DQ stands for doubly ended queue. Doubly ended queue. Now what does this term doubly ended queue means? Let me write a proper definition for this. DQ is a data structure. DQ is a data structure in which insertions and deletions can be made at both the ends. Can be made at both the ends. At both the ends. That is okay. I will complete this part. That is part. Before that, let's understand this part only. This part only. DQ is a data structure in which insertions and deletions can be made at both the ends. Now, what does it mean by that? Say that this is our queue. This is our DQ data structure, and this is the first end, this is the first end, and this is the second end. This is the second end. Okay, now I can insert an element upon here. I can insert an element upon here. I can delete an element from this position. I can delete the element from this position. Also, I can insert an element in this position and I can delete an element in this position. So see the beauty of the DQ. You can insert the element in this way. You can delete the element in this manner. You can insert the element in this manner. You can delete the element in this manner. This is the whole logic of DQ. Let me just explain it once more. DQ is a data structure in which insertion and deletions can be made at both the ends. Now let us just think once. This end is known as front end. This end, not the front end development one. This end is known as front end and this end is known as rear end. So the definition would be DQ is a data structure in which insertion and deletions can be made at both the ends, that is front and rear can be used to perform operations. So this is the proper definition of DQ. Okay, now we studied Q. In the queue, we were following first in, first out manner. In the stack, we were following last in, first out manner. What if I say in the DQ, I can either use first in, first out, or I can use last in, first out, or I can use both. See how amazing is that? Either you can use one, either you can use two, or either you can use one and two both. So this is the beauty of DQ. Before proceeding any further, I want to talk about Newton School, due to which this video was possible. Now, what is Newton School? Okay, so Newton School is basically a platform from where you can learn anything for free and you have to pay zero fee until you are placed. Okay, and you are trained by advanced teachers. That are from IITs and NITs. You get an assured placement from among 300 plus tied up companies, and these companies are none other than the big companies such as Snapdeal and Unacademy. Okay, and you get an assured package of 5 lakh to 40 lakh CTC. And you get a doubt support. All the exercises and all that. Now they have an exhausted 6-month web development program in which you are trained from beginning to advanced, and you are made a proper web developer which the industry needs. So make sure that you check out that. Now under Newton School, they have one initiative which is known as Launchpad. Now this initiative is taken up by Newton School to make India developer powerhouse of the world. Now under this, like, okay, just a minute, this is different from this. Under this you get various courses for free. I mean various, such as web development, stack development, Android development, C++, operating system, machine learning, deep learning, all for free, and you have to pay zero fee. And if you complete the course from the Launchpad section, you get a certificate of completion, you get a doubt support. They want India to make developer power of the world, so that's why they have taken this initiative. So make sure to check out the Launchpad section and just utilize your time properly. Okay, so now let's proceed with the DQ part. Now have you having a one question in your mind striking again and again, like, why DQ? Why DQ? This is the question, why DQ? We have studied so many data structures as of now. We have studied array, we have studied stacks, we have studied queues, we have studied strings, we have studied recursion also. Recursion is not an algorithm, data structure, but is an algorithm. So we have studied so many things, and why do we need a DQ data structure? Why do we need this? Let me tell you its proper application part. Let me just tell you its application, and once you know its application now, you will be like, okay, this is important now. Okay, just a minute. Yeah, so take an example. Okay, just a minute. Say that this is your Google Chrome. And you came at day one. And you search for some of the websites, such as, let's say that newtonschool.com, and then you search for LinkedIn, then you search for leadcode.com, and this you did for the first half an hour, and then you close the tab LeetCode. Now you want again that LeetCode tab to be open, but without searching. So Google Chrome give you an extension which is known as Control plus Shift plus T. So what it will do, it will open the recent closed tab. Okay, it will open the recently closed tab. Now how this is helpful? Actually, what are you doing here? Like, okay, let us stop this point over here. You open the tab. Now after day one, you saw your history, and the history shows all the things that you have stored. Okay, now the storing capacity, the history storing capacity of Google Chrome would be some like up to 10 lakh pages, 20 lakh pages. It would be some extent now. After that it would be over. After that, what Google Chrome will do, like example, say that this is your Chrome history, and the storage for storing the history is over for Google Chrome now. Now what it will do, it will just pop this one and add this one upon here. And as it can also just pop this upon here if you use some extension upon it. So this is the most used application of DQ. What? History actions, maintaining the history of actions. This is the main use of DQ data structure. The history saved in the browsers and all that is implemented via DQ data structure. Okay, now another application of DQ data structure, as I told in the initial parts of the video, that stack is used in the LIFO manner and the queue is used in the FIFO manner. Now this two, the function of both two can be performed by DQ. Yes, DQ can be worked as a last in first out and first in first out. Like you can do insertions, you can just combine these two and use them to form stack and queue. Okay, then we have also various application of this, like such as for some problem solving skills, such as sub-array problems and all that. And also this can be used in various CPU scheduling algorithms. Like if you have studied the operating system subject, there is a part which is known as CPU scheduling algorithms. In that, the DQ data structure is used. Okay, so I hope you understood the gist, like why we have to study DQ, what is DQ and all that. Now, in many parts of the video, I always say that there are two logical data structures. There are two logical data structures. One is array, and the another one is linked list, So there are two data structures which are logical. Now, how can we implement DQ with the help of these two logical data structures? That is our question. Okay, before that, I want you to know about linked list. Actually, this is not that much important, but yeah, if you want some more clarity in your mind of your thought process, let us just discuss about the DQ ones, linked list ones. Linked list is a data structure in which this kind of a thing is used. Actually, these are the nodes in linked list. There is one of your element which is connected to another element, it is connected to another element, and so on. Imagine this as a string containing the pebbles, like this one. This is beads of the necklace in the single line. This is a linked list. Now there are two types of linked list. One is singly linked list and the another one is doubly linked list. Singly linked list is one in which the data structures only have a connection which is in the forward way. But a doubly linked list is that in which we have the connection in both the ways. Just this part we have to understand for our DQ data structure part. This is the thing okay, just let me, yeah. So there are connections in both the ways in the doubly linked list. Now, one more point you should know, in this, insertions are easy, but deletions are not easy. Deletions are costlier because in the DQ we want deletions at both the end, and here deletions at both the end are not that easier. Like if you want to delete back one, that would be much easier and kind of that. But in the DQ, you want insertion deletions at both the end, and it would be costlier to use this. So the main point is that the linked list, if we want to implement DQ with the help of linked list, we want to use doubly linked list. We have to use the doubly linked list. Okay, and in the array type also, we would be having one is the naive approach. What would be the naive approach? To use the simple array and to fill the array in this manner. And from front and back both. But this would be not an easy one because if you want to delete it, you have to move here, it would be not easy. So again in the array, we would use the optimized approach, which is the use of the circular array. Let me just clear this one and write more cleanly upon here. So how can we implement DQ? Either we can use circular array or we can use doubly linked list. So these are the two ways upon which we can implement our DQ. What is a circular array? A circular array is that in which we have again resize is equals to resize modulo 1. Okay, I will not go in there. This was an interesting topic, like this one, and we can keep track of both the ends, and doubly linked list is this kind of a data structure. So I hope you understood the gist of the main part, like how we can just implement this using the array and the linked list. Now let us take an example to understand this more clearly. Let's say that this is my empty DQ. This is my empty DQ. Let us think like this. It is our empty DQ, and let us call it as D. Now we are proceeding with the following queries. We have to insert an element 100 in the front position of D. Okay, we will do that. We just inserted 100. So my 100 would become my front as well as the rear element. I talked this in the earlier part also because only we have single element, so this single element would become my front as well as my rear element. Okay, now I want to insert I want to insert 200 at the front position of D. So it would become 200 and 100. Insert front means this is my item, insert front upon here, so it would become my front and it would become my rear. Now I have to insert 300 at rear position of D. So my D would become 200, 100 and 300. So this would become my rear and this would become my front. What does rear means? Example, this is my last element, so insert upon here. Front means this is my front element, so insert upon here. Always remember, when we have to insert in the front, we do left processing, and when we have to insert in the back, we do right processing. This is the easiest part. Yeah, this is the easiest part. Now let's say I want to insert 400 in the rear position of D. So it would become 200, 100, 300 and 400, in which it would become my front element and this would become my rear element. This is a simple thing. Now let's say that we want to delete an element from the front. So simply this would be removed. This would become my front and my DQ would become 100, 300 and 400, and this would become my front and this would become my rear. Now let's say I want to delete an element from the rear. So this would be removed, this would become rear and my DQ would become 100 and 300 and this would become my front and this would become my rear. So can you see that how is this DQ? This is the most awesome data structure, and it will be used in various problem solving techniques. Okay, so this is one kind of a DQ. We will see the STL implementation of this. Now C++ STL implementation. How can we just use this? It is simple. Hash include input output stream and hash include DQ. C++ is a very interesting language. You can use this various purposes using namespace standard. Actually, if you see, these both lines can be saved by adding this one, hash include bits/std c++.h. Actually, the code one is like small one, so I just preferred writing it rather than pasting the screenshot of my code. So int main, then we will be having DQ as it is a template, so int type and the name DQ. That is simple as that. So now we can say that DQ dot, there are various functions. Let me just write the functions. So these are the functions of the DQ. One is push front, another one is push back, we have dot front, we have dot back, okay, and then we also have pop front and we also have pop back. Always remember, we have in C++ we have two things. In C++ we have two things. One is push, another one is pop. And in push, like in stack, there is nothing push back front, so simply we use push and pop. In queue we use push front, push back, front, back and all these terms. In that of the vector we have to insert it back, so we use push back. This is the only thing, right? So we can say that dq.push front, dq.push front 10. We can say that dq.push front, push back 20, dq.front, dq.back. These are all the functions which can be helpful in that of the queue. And we can also initialize it with the help of this syntax, dq int dq is equals to 10, 20, 30 and so on. So this is the kind of data structure which we can use. Now if we want to iterate, we can use either iterators. I have explained iterators in the previous video. If you haven't watched that, make sure that you watch the iterator video. We can say that auto iterator is equals to dq.begin, and we can use this to iterate over the queue. We can also use for loop to iterate over the DQ. This is the availability in C++. So this is all about the DQ ones. So if you have any doubt, make sure to comment it out and make sure to do questions on this. Actually, there would be not a lot of questions, there would be lesser questions in this topic because these are not mostly asked. But make sure that you do some questions on DQ so that you will get a hint of DQ1. Okay. So if you are any doubt, make sure to comment it out, and if you are happy, make sure to like the video. Okay, bye bye.